Okay.
I did some research, especially using the chat, and while I didn't find like research papers on biochar and filament,
Mm-hmm.
most of the comments that I got on the chat, it's that the specific functions that need to happen on the blueberry plant, the biochar plus the filament would be a perfect solution. Not separate, but each other, they do complement on a perfect function. What I mean by this is I'm just gonna go to slide number 3, and I made some reference information there. So I put the function of cocoa coir, and then I did the functions of what could be the spaghetti biochar or the filament biochar, if we can call it
Uh-huh.
the growing media. So what is achieved on cocoa coir is porosity and structure, but that's basically for have some airspace on the roots. So going into the filament biochar, I think that would be even much better because it doesn't crunch. Water retention, yes.
Crunch?
Well,
Crunch?
what's the other word that you use that when it's like this and it just goes lower? Condense.
I missed the question. Say it again.
So when you have the cocoa coir, you put it and it's kind of tall, and then when you're putting water, it starts condensing.
Ah, yes. Okay, okay, yeah.
That's what I meant by crunch.
Firm.
But
Firm.
yes. So water retention, what is gonna help the filament biochar? It's basically the biochar. When integrated into the filament, it gives the function of absorbing some water and being able to transmit it to the root. The nutrient buffering, it's same situation with biochar. That's the main function that it will do. Of course, the formulas are going to be specific by volume of liter of water, and it's going to be made by pulses, which that's going to really help the root to be able to absorb the nutrients that it needs, each pulses of water. And there you can see microbial life, stability and reuse. That's applies with plastic biochar, which can be recycled fully. And pH management shouldn't be an issue because water comes already treated with a specific pH that we need on the blueberries. That is from 4.8 to 5.5. That would be optimal. It can vary until 6 at max.
We can achieve it with biochar.
Well, yes, biochar can help with that, but most of it is with a water formula with acids,
Okay. Okay.
which is a common practice right now. Even that we use cocoa coir, we put acid into the water so we can make it on 4.8 to 5, and then we put formulation, and that's how it goes into directly to the plant with a regulated pH before it gets into the plant.
Nice. Okay.
And on that same slide, on the materials, I did some research about the cost of the different polymers or plastics in this case. And what I focus on is since we're going to be working with food and we don't want any not safe practices, I just put the plastics that are already used in the food industry, which is HDPE, PP, PET. Those plastics are used in not on irrigation systems, but also on trays where fruit is harvested, and also on clamshells where fruit is stored. So what I'm trying to say here is the plastics used are already permit. They have permits to be used on the food industry, and it shouldn't cause any issue.
Yep.
Now, on the prices, I put typical price range on Mexican pesos per kilogram, and I also put the recycled price. That's an average since I haven't recycled yet. That's what I found on the internet. And also the average density of kilogram per cubic meter, just to make a relationship on the density of this. And what I found is plastics new, they're very similar cost per kilogram, and recycled, same situation. I think it's half of the price, maybe recycled, could be a little less. And on the biochar, which is the other important part, since I'm thinking doing 50 and 50, 50% plastic, 50% biochar. I found that depends on the source where you get it. But as an example, I put the cheapest one, which is from bamboo. New one, it's 10 Mexican pesos. That would be zero point 0.40 or zero point 0.50 USD per kilogram. It could be much cheaper, I know, but just as a reference. And recycle, making it ourselves, would be 4 Mexican pesos. That would be zero point 0.20 USD. And the density is 250 kilograms per cubic meter. So that's a reference structure just to start ideating what could happen if we're able to transform this
Yeah.
into final product. One last comment is about the size of the pots. Just talking with the chat, I understood that since we're doing a different design, the number of liters we used before, I mean the 30-liter pots, they're not needed anymore. We can go even half of that on size and focus on 15 liters pots. Now, not really sure about it.
Because hold on, because we're using why? Why?
Because we're using plastic filament in biochar. So I mentioned about the coir. When use it, it can condense, or I
Yes.
forgot the name. When we're using plastic in biochar, since plastic is a more fixed or stronger structure, it's not going to condense. So the root, they're going to have more air, they're going to be happier, and the plant is going to grow better. That's the solution, that we don't need so many liters just to eliminate the risk of condensing of the growing media. That's the benefit of
Wow.
this.
Huh. That's great.
That's slide number 3, which I think is the reference, the most important to start ideating how can we make this happen.
Yeah.
Just on slide number 4, I just put 2 pictures I took this year of blueberry plants, 4 year plus, 4 years of age or more. On the left, you can see this is a blueberry plant. The pot is upside down, just to put it as a base, so we could see the whole growing media. What you see right here, that's coco coir, and that's the actual structure that is used. That's about 30 liter of coco coir, and the
Yeah.
rest is a happy plant. And
Wow.
to the right, it's also a blueberry plant, but that's on the soil. It should have the same design. I mean, if we could see the roots below the soil, but in this case, we can't. That's just for reference. When we're thinking about what the pot has to do, it basically has to give a structure so the upper part of the plant look like this in terms of branches, in terms of fruit per centimeter regarding each branch, which that gives us the productivity of units of fruit that give us the kilos per plant. That's the structure we will love to achieve with this new design of plastic biochar.
Structure of what?
The structure of the upper plant.
Upper
So
plant.
below, we want to work with the roots, but upper, we want to create branches, leaves, and fruit.
What's the difference between the soil version? Does it look? Is it as good? It doesn't look as robust.
That's correct. So it's not as controlled as you would do on a pot. So for that same reason, the development is much slower and less controlled in terms of quality, in terms of size, and in terms of even fruit flavor and structure.
How does the fruit flavor compare?
Bricks, that's the main way you can measure how acid and how sweet it is. And also the size of it.
Do you have a value?
Bricks, yeah. So what the industry looks for on premium is 11 plus, 11 bricks plus.
I'm asking, okay, 11 plus reference. Do you know what these specimens have achieved here on the left and right?
Yes. So the left has achieved 14 bricks, and to the right, these have achieved around 10,
Oh, wow.
9 to 11. These pictures I took them this year. The left one is in Peru. The right one is in Fresno, California. Same company, same genetics we're making that project with. These are the MBOs. It's just different references of production and also climate.
Wow. Climate, how's the climate different?
Uh, Peru is more stable during the year, so they don't have any frost risk. They're basically between, I'm gonna talk in Celsius, from maybe 12 Celsius to 26 Celsius. So the plant is basically very happy and productive the whole year. I mean, that's very good for blueberries at least.
Yeah.
And in Fresno, I'm not really sure, but they do get some cold in the winter and some heat in the summer. I'm talking about maybe 35 Celsius, that's their heat, but that's hot for a blueberry plant. So they have to harvest earlier, maybe at May at max, maybe June.
Wow. Okay.
And slide number 5, and I will finish with this. My part is I put the 3 main business strategies that need to happen to automate this business and also to reduce cost of next. The first is the mechanical harvester, and I did the reference data on parameters such as row spacing needed, in-row plant spacing. Then if we talk about the structure of the plant, the crown width, and also the design of the plant that needs to happen, we call it a Y. Well, in this case, it's throat, but it's honestly like a Y letter, what we're looking for. The plant height, and those others are basically turn headlands. Is when you finish harvesting the line, you need 7 meters to turn the machinery. That's what it means. Then
Seven
the
meters? Sorry, 7 meters is what?
7 meters is the distance needed at the end of the line to be able to turn the
To
mechanical
turn.
harvester. Then on number 2, I put mechanical pruning system. As you know, pruning is very important to rejuvenate the plant and be able to have a strong harvest next year. This is done with people,
With
or
an
it can,
open source pruner.
yes,
Okay.
or it can be done with
Oh,
mechanical. And
hydraulic head trimmer for tractor. Oh, this is some perfect territory for open source. Yeah.
yes, and number 3 is the plant structure. What it needs to have is just how many canes, 8 to 12 mature canes, how many years should it have at max so the plant is rejuvenating. So if a cane has more than 4 years, you can see that by the structure of the cane, it needs to be cut in order to maintain productivity during the 7 to 8 year cycle of the plant. Fruiting laterals, that's like the fruiting leaves well, the branches that produce fruit, lateral length and leaf root radius, root volume, and crown diameter. Just if we go to slide number 7, you can see a picture of the shaping, what I'm talking about. You can see that
Yeah.
it needs to have a Y, but very important, and I'm mentioning this because of the design of the pot. In order to be able to harvest at least 95% of fruit for fresh packing,
Yeah.
the lower branches need to be higher than 50 centimeters from ground. So that's why it's important how we prune them, what kind of mechanical harvester is used, and of course the shaping of the plant. The height, I believe it can be also assigned with the design of the pot that we're making.
Why 50 centimeters? Catching.
Because on the air harvester, well, on the mechanical harvester, it has certain discs that rotate. So we want those discs to be at least at 40 centimeters or 30 centimeters. So when the harvester is blowing the fruit,
Yep.
it gets into the disc that catch the fruit
Okay.
and get into the trays directly. That's the whole mechanical design that I wish to achieve. Besides what we're talking about, the growing media and how to make the pot.
Yep. Beautiful. Okay. So you got considerations for shaping as well for harvest. Yeah.
Yes,
How do you design a pot to be to I mean, we're optimizing pot design for robust growth. I mean, beyond that, you can't. I mean, I think the way to look at it, are you looking at it as basically high health, just super health, robust plants, right? That's all. That's the metric. I mean, the metric is health. I mean, the bricks, all of that, all those. I mean, plant needs to look absolutely healthy and all that.
correct. Yes.
Yeah. Mm-hmm.
The height, I think it's more, yeah, the pot needs to have certain height, but it's more part of pruning structure.
Yeah. Very nice. Um, any more slides to show? You got 7.
Yes. Well, I got number 6, which is the summary of system limits. Row spacing lower, 2.5, upper 3, and then I put uh, profit quality optimum, which
Mm-hmm.
is 2.6. We don't want it to be too tight, but neither too much, since if we put more plants in certain area, it's going to cost less. The rest of the materials, such as the bird net, such as the sunshade, as an example. The in-row spacing, lower limits 0.7, upper limit 1.10, and same formula. But in this case, I need really to find out if this makes sense. What I mean by this, if we put plants in 0.7 in line, it's gonna be, I I would say 5,100 plants. But if we put it at 0.8, it's gonna be 4,900 as an example. I'm not being super specific now on the numbers, just as an example. So what I would like to understand, how can we find the perfect ratio of how many plants we put based on the plant growth and the ability to harvest correctly? That would be the decision to understand, to do the plant design.
Yeah, I mean, that's a secondary thing to do to look at, right? Like first is um, first problem statement is that the plants are growing, right? I mean, we can optimize that once we see the health of the plants. Is that so or no? Like the characteristics of the plants. What if the yeah? I mean, what are your thoughts? How are you? I'm not sure why you're going already to details of spacing when that's is that something to look at outside of knowing that okay, here's a range. Are you trying to? We're not optimizing that range yet at this point, right?
No, I just want to understand what would be the plan design, because based on that would be the volume of units we need to print or the number of plants I need to buy.
Right. Where does the say the 50? Because you can optimize for okay the ease of the I don't know. There's different things you can optimize. It would be like maybe by virtue of the irrigation system, you determine your number of rows by that. All those factors are going to play with each other, like contribute to each other. So, I mean, this is something that we find out in the process. Like the first thing is to do that pot, for example, pot irrigation stuff, right?
Yes, I agree. I
Mm-hmm.
just went all the way through just to
Mm-hmm.
put like the final details that would be important as well.
Yeah,
But let's start from the beginning. I
yeah,
agree.
yeah. So you're looking ahead into all these factors, including harvesting and all of that. Yeah. And how prejudiced are you for existing machines? Like, what if it turns out that you know, the for example, Y shape is that? Are you sure? What about?
Yes, I'm sure not just because these machines say so. It's because if I look at the mechanical harvesting industry, they agree 100% that this is the way to go
Mm-hmm.
because of the fruit loss. If
Yeah,
it's not shaped this way, when it's shaken, or in this
yeah.
case, fluid with air, it's gonna drop to the floor, and that
I
happens a
see.
lot.
Yeah. What angle? They say anything about angles? Do you want to make a wider Y or narrower Y? 45 degrees, 60, like 30. What do you? I would say like a T, like the most shallow. Um, I would even go to say, you know how there's apples that are espaliered and they end up growing horizontally like grapes.
Yes.
What do you think of this? Does anyone say that you want the high? When I say lowest angle, lowest angle from the floor, right? Do they say that, or they? What angle do they say right now? What's the industry standard? Nothing. They don't have anything, any specifics. Just wanna get anything. That's why.
Not that I know, should be any specifics that I can tell right now.
Yeah, yeah.
I just know that this angle, you mentioned T, which should work as well, or Y, it's basically when it's shaken, the fruit has the ability to get out of the pot design and go into the harvesting machinery. So it doesn't stay on the center.
Is it possible that you go to a more linear? I don't understand how blueberries grow. Can they grow linearly? Like, do they always have one plant, or can you extend it, like make a narrow, elongated root system? You think that would work, or no? Absolutely not. You got to have the round, the standard stand, as opposed to elongated pot.
Yes.
Can you do
You,
that?
you can you can guide them for sure. I mean, not the root, but the branches, they're gonna be growing at certain design. And if you guide them like with a trellis, that could happen on the way you want them to be. I don't know if I got your question.
Can you shape? Will it be healthy with not a circular root ball, but elongated root ball? How does the plant handle it? Because some things are like bamboo, right? It has root systems, rhizomes that can take over fields. Does a blueberry does a blueberry sprout up from new roots? Do branches come up from roots underground? Like if you spread the root system with more branches, would it be like an elongated plant, or no? It's not how it
Not
works.
not really sure about that, but about the other question, based on pot design, there are pots which are circular, there are pots which are rectangle, squared. So your question is, if you do a different design of pot, like a rectangle, that could work as well. I don't believe that the design of the root is going to make the design of the branches that are going to fruit.
Yeah, that's something to see later. Does do blueberries sucker, meaning branches come out of a root underground, or no, just from the main trunk?
There are some of the branches that are suckers, they are minimal, and the practice is to take them out.
Mm-hmm. Do they ever? Why is that? Because
They don't produce fruit.
they don't. Mm-hmm. Okay. Yeah, yeah, yeah. So we're here. We're from here. So we're so so to review, we're saying that through chat, you got to some conclusions that if you use a more favorable medium, you can actually shrink the pot size. That's your
Yeah.
conclusion?
Yes, I haven't validated, but most of the references make sense.
Has anyone done it?
Not that I have seen on
So this is
blueberries.
theoretical.
Correct.
Well, interesting. So you're getting to the edge of knowledge already, eh? Did you read about edge of knowledge on the wiki?
Nope, not that I
It's a
remember.
it's a concept. It's a concept that that's the point. Like already, like when you delve deeply into something, there's so many edges of knowledge where it's like nobody knows. And that's yeah. There you go. That's good. That's innovation. Room for innovation. Okay. Interesting. So that's. I mean, so you're. I think that's progress, right? That's it's fascinating, right?
Yes,
I
I
mean,
would say now can we go to a certain validation form of this?
yeah.
Would be great.
Well, let's do it. So I mean, we can. If a plant has more than 32, like in your standard cocoa coir, if they have more volume, do they produce better, or is that
No, no, it's basically a strategy. If you don't get enough water one day, you have a buffer of humidity, so your plant doesn't go dry.
but what would happen if you used more volume?
You would have less risk because if all your substrate is wet, then if you don't get,
Less risk. But what
yeah,
about plant size?
not that I have known about these people they're producing in Peru or California with pots both.
Hmm.
I have never heard about someone that has put a pot of 60 liter as an example and have gotten about 15 kilos per plant. That relationship at certain size, it doesn't give more kilos.
I see. Okay. But now we're seeing that, oh, we can actually go lower and still get positive results. As good. As good as. We're shooting for as good as.
Yes, I mean the reason the industry has gotten bigger on liters of coir is because of the hot weather.
Ah.
That's it. Commonly, they even use 20-liter pots before.
Hmm. Now, does that change with hydroponic, aeroponic?
If the design of the pot is going to be able to conserve some water, which is going to be creating humidity that the roots can absorb, of course, it changed a lot.
What about the risk? If you have more buffer, is the problem with more when there's more buffer, does that mean that the irrigation system is not robust enough? Like, for example, it might go too long before, and then the plant dries. So it's just,
That's it.
mm-hmm. Okay, so you have to figure out those specific parameters. Okay, so what do we want to do now? Go for, so we're looking at biochar, and when we say biochar 50/50, how much of that is in a filament and how much of it is loose? Like, are you talking about embedded, biochar embedded filament? Or,
That's what I read. The ability to embed the biochar through the filament. I don't know exactly how that's going to happen,
huh,
but that's what I got.
and there, all that 50% is in the filament?
That's what I got, but I
Okay,
don't have the answer.
okay. Um, let's push it. Yeah, we know it's at least 30%. It's 30% at least. Yeah, that's Dr. Pierce. He's done some of that. So we should ask, for example, Alessia. She's a PhD student in his class. She's done a little bit of looking into the biochar embedded filaments, so we can take a look at that. Hmm. Wow. And what about, so it's, if it's 50/50, the trouble would be at the end of the day, the challenge is, can you still, for example, print with it? Like if you want to print spaghetti, or does it fall apart because it's got too much biochar, and therefore it doesn't, not enough plastic material to actually stick together? See what I'm saying?
Yes, and the reason of the 50-50, I went because I read it was possible, but most of it was because of the price per kilogram, which is the cheapest material if we compare plastics to biochar cost per
Yeah.
kilogram.
And how does the cost per kilogram for biochar compare to cost per kilogram of coco coir?
The cost per kilogram on cocoa coir is 0.09 USD. And you asked me about biochar.
Yeah. Point
The
nine? What happened to
2.8, it was of the 30
it's
liters.
2.8? Yeah. Okay.
That's so I went 2.8 divided by, sorry, 30 divided by 2.8. It's 0.09
Okay.
per liter.
Per kilogram.
Per, no, we put 30 liters per pot on volume wise. And that's how I got the 2.8
Mm-hmm.
US dollars for the 30 liters.
Yep.
So I need to make the conversion, you're right, liters or kilograms. That's what I'm missing.
Um, Here we go. Okay. So my notes here. So bottom line was 2.8 US dollars per pot for about 32 liter.
For a 30 liter, yes, 30.
And then zero, so 9 cents per liter. I think we said it was like it was about $1 a kilogram. Didn't we say that last time?
I think so,
Sorry,
yeah.
for coco coir, right?
Yes.
Let's say that's that. And then what's our baseline for biochar?
By kilogram,
Yeah.
10 pesos would be 0.50 USD per kilogram. And zero point 0.2 USD on self-made biochar.
Okay. So for commercial. So why isn't everybody using biochar instead of coco coir?
I would say industry standards. When you're going into the business, you get to the suppliers that most of the successful people recommend you, and they have certain systems that already are working, and you don't move much the structure because you don't know how to. This hasn't been validated. So if you tell someone to use biochar, they're going to ask a lot of why.
And chat is indicating smaller space, and and also at 50%. So significant savings. Okay, so we got to test all this stuff out. So how do we start? Um, is there good indication that biochar? Have you looked into whether um, what's chat say about feasibility of biochar? I mean, you said there's, yeah, it's positive. It has the various functions. You can control pH, etc. What did it say about? Did you ask why? Well, when you say industry standard, is that chat answer or is that your answer?
That's advisor sensors.
Advisor, yeah, industry standard. So it could work. It may well work.
If we're seeing the functions that we need to do specifically with the growing media, it should work.
Yeah, but that's stuff you can test like immediately with just start some pots with it, right? What's your no?
No, yes, I can. And next week I'm gonna bring the plants to the trial site. So it would be perfect to do it as soon as possible, so I can start from the beginning, from 1 liter plant until development of the material of that plant would be year 1 and year 2.
That's interesting. Because right now you can do. What if you get biochar and print? So step 1, get a 3D printer. Step 2, just get a spool of sample filament. Step 3, mix biochar in there, and is that a decent growing medium? Like not even embedded, not even biochar embedded filament, but just. Would that work? Maybe not. I don't know. How critical is the idea that the biochar is embedded in the filament? Because then you get more airspace in that filament, right?
Yes.
Moisture retention.
Yes. I think we would need more.
These are tests. You want to start exploring like tests of, like, just get some of this material and see how it behaves, right? So,
yeah.
But then it makes me question. It's like, man, all right, so why hasn't anybody done that, right? We're gonna because the world is retarded. Is that the answer again?
I wouldn't express like that. I would say when you're a farmer and you're starting something, you go with an expert and you go with an advisor, and that advisor has certain systems that work, and that's how you follow. So that's how I would express this.
Yeah.
Sometimes innovating and researching that costs money, and since it's a business for most, I don't think it's a risk they want to take.
We understood, but where are all the innovators? Just you and me, baby.
No, I believe they're in the labs writing papers, not in the field, being able to show how this works with their own money. That's the big difference.
See, that's why you are unique in that, and I love it. Yeah. Okay. Yeah, no, this blows me away. It's like, holy cow. That's amazing. Why hasn't anybody done it? And I say that about a lot of things. Like, for example, the thermal battery, which we're implementing. Yeah, so this... That's great. That's great. Okay. I love it. Okay, so get some biochar, start playing with it. Like, how does it behave? That's the question number one. Like, can you mix it with spaghetti? Like, if just get a 3D printer and start printing spaghetti, like failed prints. We print failed prints on purpose.
Yes.
We failed prints on purpose. And how does it mix? Yeah, we gotta start experimenting. So what would you say is feasible to do right now? Like, I mean, this is where you just got to get your hands on some of the material, and then different types of biochar, because different ways that biochar can be prepared. Like, and do we know that the stuff that actually works, that's activated biochar, is that the stuff that's about 50 cents a kilo, or
yes, that's the one.
Activated biochar.
Activated biochar for agriculture. That's what I found the price, which is put into the soil and has the functions we're looking for.
Yeah, well, I mean, just get. Do you have some of that?
I can get some of that, yes.
Where do you get it?
Online, Home Depot. Mm,
Home Depot has it.
yeah, all the I wouldn't say all, but some agriculture companies that sell inputs, they can get some as well, especially the organic ones.
Um, where's your nearest Home Depot?
5 minutes from here.
And they have it, so just get some and
In the garden section, I saw it.
mm-hmm. Yeah. Wow.
Not not this price, but at least for some experimenting, or I could purchase
So what do you
half.
know about 3D printers? What are we gonna do? Are we gonna build our own? We haven't touched ours for about 3 years. It turns out actually William Neal, who is in Canada, I visited on a trip. Is one of the first dedicated project visitors at Factory Farm. Actually, turns out he has an OSE 3D printer that he's using, which I didn't know. I don't have no idea how many people are using those out in the wild. Do we want to build one? Do you want to like get one tomorrow from China? Build one would require, we would have to gear. We gotta basically gear it up here too for our program now. I'm super busy till December because man, so we basically the whole workshop is filled. We got like 25 people right now already. It's amazing.
Yeah.
So, oh yeah, by the way, the 4-minute promo video went out on Instagram today, so it's hopefully that I actually saw a new application for the Future Builders Academy today, so I gotta it might be working already because it's out
Yeah.
there. So, but we got to get our 3D printing infrastructure. So what are we doing for the 3D printer? Do we want to get right in? I mean, do you want to start looking at the BOM for the 3D printer and actually start making one, building
What
one?
would be your recommendation? I mean, importing from China,
Um,
yeah, could be an option, but that's going to take time.
China? Are you talking about China or OSE?
Yes. You mentioned about importing from China printer, but I think that's feasible in cost, but it's going to take a little more time. How long would it take to make my own?
It depends how quickly you, how aggressively you take it. You can have it if, let's see, the supply chain. You have how long does, for example, Amazon or do you have eBay?
No, we have one called Mercado Libre.
What is it called?
It's Mercado Libre. That's kind of eBay, but from Latin America. There we can get same components than eBay.
Electronics. Have you
Yes.
looked at Have you looked at the 3D printer bill of materials on our wiki?
Not
Okay, why
not
don't you take a? Well, you can answer this question. I mean, you can go on the wiki right now and you can go at D3D the product release. What is it, 16.04? And see if you can get all the parts. Build one. If you get the parts in a week, you can build it in an. If you assume learning curve, I mean, if you do it yourself, we can. We haven't touched it here. We have basically all of them in storage and taken apart and stuff like that. We got to get back to it. So um, let's see how to do this best. Start by looking at the bill of materials and see if you can get all of that online. And we might as well build one and start making 3D printers again. William has the latest. I know Alexa has got working printer. She's got that one going on, the latest model, the one with the rebar frame. And actually, I would just suggest build the one with the rebar frame. Yeah, the frame is not stiff enough. If from what I see, you can make a. It's not stiff enough on a 12-inch print bed. So do the standard one, the D3D. Okay, let's look at 3D printer genealogy.
I'll look at the parts of the 3D printer. I'll let you know what I have available here in
Yeah.
the region, and we can start from there if it's
And
more
you have a.
convenient. Yes.
Do you have any welders on staff?
Yes.
If you do, yeah, okay. If you do, then you can build one real quick. You don't need to weld. There's one version with 3D printed parts, but that actually gets into the, if you do, so for 20.07, no, not that one. Pro 2007. Okay, so that's 20, so that's 5 years. That one, that's good. That works. Only an 8-inch bed. Wait, but we just said we can't. This would suffice for the smaller pots, right? If it's got 8 by 8-inch square. Before we're talking about 12 by 12. So 8 by 8 would be the half-sized pot.
The 15-liter
Yeah.
pot. Well,
Yeah.
that's how they call it in the industry. We can start calling it by centimeters or by inches, as you wish.
Oh, whichever. I'm used to inches because we've been in this country for so long. But
Yeah.
8 inches is 8 times 2.5. What is that? 20? 20 centimeter bed? Yeah. So volume of 20 cube in liters. Volume of oh no, it's only 20 centimeter side is only 8 liters. Oh, what? 8 times. Oh yeah. No, you're right. Oh, we would have to go. No, that's 8 liters. Half the size. So you could build a printer that's twice as tall. Just elongate the Z. No, let's see. Let's do the 12-inch bed one, which is, I think we want to go straight to the 12-inch. I mean, for 8 inches, nah, that's a little small.
I'm gonna paste in the chat a supplier website.
Yep.
There are the different sizes of pots with, I believe, with the size.
How do you say that?
Pots.
No, the website. Oh, that's
Where did you who?
where did who?
Those are my current suppliers.
Okay. So which one specifically are you using?
The 30-liter would be the
Second one.
second one. Yes.
Okay, so do we want to go with, do we want to start with the half size or just go full size and just replicate that at half the cost? I mean, just do it incrementally. Why don't you want to go simple, like do the big one still, or no? Or just skip that and, I mean.
If we can do that, yes, I listen to you.
What did we say last time? It was what, 5 pounds? Do you remember how much weight that was? Let's look at our notes.
Yes, I'm doing just that. I think it was a pound or 154.
Oh yeah. Oh. Yeah.
Container weight 450 grams, almost a pound.
Yeah. So yeah, I mean, you can print one spool of filament. Will get you 2 of them. I mean, I think we should just do that. It's not excessive. And then we know it's going to work in a larger pot. Now we're trying to say, oh, we're actually going to start creating more airspace with. But let's just do that. What are your thoughts? I would just.
Same. I think if we start changing too much for first prototype, it could work. But at the same time, if it doesn't make a very different cost cheaper, staying with the same size for now would be a good step.
Yeah, which mean, look already. If we just printed successfully, we've just won already, right?
Yes.
How much is one of those?
On cost?
Yeah.
One moment. I'm going to open the document.
That website seems to be bad. It's when I click on the detalles of the 30 to 33, it takes me to 25, 27.
Okay, I'll look for the specific documents where the sizes and all of that is, and I'll put it on the working document.
Yeah, let's do that. Let's just start. Let's go in just in simple steps. Step number one is, okay, what's our print cost using standard filament? Now we're going to do open source filament, and what's our print cost now? Because that would
Okay.
be. So do you recall what's your basic cost of that single pot?
I'm at the document. I just need to find the specific. Okay, the cost of pot would be 1.5 USD.
1.5 USD. That expensive?
Yes.
We won already. I mean, if you use. Oh man, we can easily beat that. How come it's so expensive?
Because that's a plastic pot. The black one we're seeing, and they put a special design that supposedly the wood develops better. I tried them last years, and honestly, versus the white bag, it was almost the same result. The only difference is that these are heavier, so they don't fall so much when there's like strong wind.
I see.
If we go to the white bags, that would be much less. That's about 0.50. But then
$0.5?
yes, I'm talking about US dollars. But then those white bags need a base that costs another 0.50. So it's 1 USD versus 1.5 USD for the black.
Huh. So we should write up. So what are our steps like for victory? So let's go let's start prototyping this stuff in simple ways. I mean, we're already winning just by print, I think, from what it seems like, which to explain why nobody does that, let's see. So if you use commercial filament, no, it's not cheaper. So yeah, nobody's going to do it because nobody makes their own filament. So, I mean, this is seems like such low-hanging fruit. Conceptually, it's low-hanging fruit. Now, it's going to take the dedicated work to actually make it happen, right?
Yes.
Yeah.
What I understand, if we talk about cost, we saw that the most expensive per plant is the irrigation system. But understanding that that has done before, and also the automation part has done before, I would say that can be done. The only thing that hasn't been developed and proven is the alternate coir. There we're talking about the filament and the biochar, which this is one of the most expensive per plant, And that's, in my perspective, what we want to do now in order to validate it. And from there, if we validate that, then the rest is just gonna start making a compound value. What I mean, growing media works, okay, then design the pot, that the pot is like the other pots, but the difference is gonna have a water relief system and also a single reservoir per pot. Then it's the irrigation system, which, as I mentioned, that has already been proving how to do it, as well as the automation parts. So for me, step number one, proving that the growing media we're talking about works. If you have other idea, we'd love to hear it since you have done this most of your life.
No, that's beautiful. I think we've got something to go on. So now um, there's probably some more chat that you can chat up, right? You can probably chat it up a little more, right? Okay, so
Yes.
let's go with that. So chat up the topic, because that's like the first level of prototyping, and then you can pick out all the good work that has been done. We can start passing it around and spamming this on the internet and get feedback. No, if we see any interesting people through chat, just contact them, right?
Okay.
Right, contact them immediately. Like the idea is that you reach out to people, and some people might get really excited because then that's how we find people in the woodwork, right? So now we're coming up with an innovative idea, and the person who has the ability to see it, we're going to make friends, right? So we're going to multiply our core of developers, because there's going to be some cool people that they're going to kind of self-select, but we're actively, throwing out interesting ideas out there. Yeah, this is good. Prove biochar plastic media works. Great. So what is step number one to that?
Print the first samples on the current pot scenario, which I mean the 30-liter pot.
Step two.
Design the pot, or at least adapt the pot where we're gonna put the sample of filament and biochar media. If we wanna just use a current pot, like the one we saw in the picture, like a black pot, and then we can adapt the filament biochar, that would be another option. But since we're open sourcing most of it, I think printing the pot would be the best option.
Yeah.
And I'm going to invest in a 3D printer, so I wish to use it as much as possible to be validating how to manufacture this in larger scale when it works.
We have to go with OSE then. If we're gonna see, because then if we change production engineering, we can be flexible, but then we might as well do it in an open system, like, right?
So I would say step 1.1 would be building the 3D printer of OSC,
Yeah.
and then start sampling the 30-liter pot and designing the pot media of filament biochar.
Well, let's do like simple steps. So I would say do the build printer, print pot, print spaghetti. No. How about we print spaghetti and just mix biochar with it? Not even talking about making our own filament. Yeah.
Correct.
Yeah. And then we make our own filament.
On filament, you mean by
Embedded
introducing
char embedded filament.
embedding? Okay.
And then we can do things. Oh man, it's gonna be cool because like ball mills, little ball mills. Dr. Pierce has all that kind of stuff, like desktop microfactory stuff. So we can do that. He's got just a little model, but then we can take our skid steer and attach weld some steel and make an industrial scale model. Okay. Yeah, that's good. Okay, so let's continue on the steps document. So, okay, so go to page, yeah, you're on 2 there. So print spaghetti. Print spaghetti. Mix
biochar.
So that means we're actually evaluating, like, how does this spaghetti behave? How does it... Printing spaghetti is a whole step, because you're going to develop all kinds of parameters, all kinds of variations of spaghetti, but also maybe like some print spaghetti or lattice medium, like crystal lattices, something which holds, can suspend the biochar. You see what I'm saying? Print this like a complex. You know how there's atoms, crystal structure atoms, like it's a whole lattice. It's mostly space, but it's got atoms in principle, right? So print the lattice, like a scaffolding, like cube of scaffolding. Literally just what infill in 3D prints is. They already do that. In fact, we can look for printing just infill without the shell. I'm sure there's... I haven't done that within Cura, but I'm sure there's... I don't know where Cura is at all. I haven't done this for years now. But I'm sure you can print just infill, because there's already formulas for 3D print infills, right? Maybe that will actually be a sufficient holding medium for the biochar. You're just mixing those two. So you basically print this infill. Say it's like a bunch of like elongated beeswax cells, you know, honeycomb, tall honeycomb, right? And you're just throwing biochar in there. Yeah, you can also like, yeah, with 3D print. So that becomes a whole experiment, whether it's spaghetti or lattice medium. That's a whole experiment. That's a whole bunch of interesting experimentation, because now it's like you're not printing stupid stuff. This is actually for growing food.
The spaghetti in the lattice medium, you mean, or the lattice medium?
Yeah, like I'm just commenting that it looks like what, you know, like just toyish 3D printing looks like, but no, this has got actually quite a profound purpose here, right?
Yes.
Yeah. So, or lattice structures. So that, I mean, you'll find a lot of stuff on the internet about this kind of, like, various complex 3D printed geometries. I mean, everyone does. Like, for example, in concrete 3D printing, people are experimenting with honeycomb-like or very optimized engineered structures so that you're not printing solid, you're not casting solid concrete, but instead you're 3D printing, using 3D printers in concrete, big machines, but you're just doing very complex geometry that gets just the right strength and doesn't waste concrete. So that kind of work has been a dime a dozen. There's a lot of that kind of work. Yeah, okay. We'll find a lot of resources on that for...
Sure.
Maybe somebody already has... I mean, here it would be, the question to ask is, does anyone, just like anywhere, does anyone already work on growing medium, on 3D printed growing medium? So when we did hydroponics here, and aquaponics rather, the stuff that goes inside the towers is called reticulated foam. It's a sponge. It's literally like a sponge, and the roots go in there to give that gives the roots structure to hold on to, and they go all into that, to just embed. And it's soft. It's like a sponge, and that's why I actually like to print with TPU, because whatever we print in that is going to be flexible and kind of softish, so we can see how that actually functions in terms of mechanical and aeration properties. Yeah.
Okay. I also added about defining the weight of the blueberry plant when it's mature. You were talking about structure and how much it needs to hold. I think that would be a good starting point. to understand how much structure do we need on the printed media to be able to hold the plant.
Oh yeah, yeah. And you can uh, engineer that in FreeCAD, finite
Yes.
element analysis, and then you 3D print that. Wow, that's a whole lesson. That's a whole curriculum for the new generation of open source enthusiasts, of open source developers of the future. Yeah, this is good. Um, I'm breaking these into parts 1.5, 1.5, 1.6, 1.7, but I mean they're all same part of the pot. But you can spread them apart, and I say that because those could be tasks that can be developed independently before integrating them all together, as in the second Toyota paradox of excessive prototyping, and then you put all those prototypes together. That's the Toyota method.
Yes.
Yeah. Um, so this is all like indoor, like bench top. We haven't gotten into the dirt. Um, have you ever looked into so Dr. Pierce also does solar LEDs, like the grow room for Canada. And I discounted that pretty much before, but if PV is free, then it actually does make sense. So grow lights. So do these plants, would they perform any better if they have more light? Or no?
If we define better by being able to have
Oh,
a
like
faster production, I mean in less months,
yeah, like they actually grow up to their full size in half the time.
yes. If the cost would be zero marginal cost, of course that
Oh
would be a
yeah.
better.
No, this
Yes,
is zero marginal cost stuff.
yes,
Holy cow, we just doubled our results in the last 30 seconds. That's awesome. I think we
yes.
should definitely take a look at it. So is that known that if you just give it like fake light, it actually is going to grow twice as fast?
It's known. It's correct. I mean,
Really?
we measure by number of light hours, how much the development of the plant goes, and by certain plant stages, we need more or less. So that's a benefit if we can add more.
Holy cow. So Dr. Pierce is one of his big projects is the grow tunnel. It's a insulated chamber for northern Canada and it's got LEDs inside. And I thought this was ridiculous initially, but actually it makes a lot of sense if energy is free or zero marginal cost. So it actually does make sense. Um, so I like that. We should definitely look into it. Now, um, the thing with him was like those growing systems for vertical growing with LEDs are super expensive. And this is once again, and he's working on all those things, just dropping the bottom, 10x, whatever, 10x, 100x lower cost, because those things are just ridiculous. It's like, I think it was like $8,000 for this 3D printed wall. It was just, well, no plastic wall, but I mean, in materials, it would be like $5, you know. So
Yes,
that's a thousand x, thousand x.
that would be a possibility for sure. I mean, the current system that we have now works because of the season that we go out, but always structuring at zero marginal cost. And I mean, by creating better the plant, less stress with this kind of technology makes sense.
So tell me this: um, does has anyone? So people have experimented with this, but it's not commercial because you got growing system costs, right?
Yes, with other fruits, with tomatoes, with cucumbers, people here in my area, they create these kind of systems because they're able to have longer harvest seasons, but not on blueberries yet,
And why not on blueberries?
because the current system of putting your plants on the sun, just with sunshade, that is working already. So if you see an investment of blueberry, are already expensive. So people doesn't want to add more and more and more since the currently setup is expensive enough, but it gives you business enough to be able to afford it.
So is it true that what happens to the plants don't need to rest at night like humans? Because you
Yes.
can't keep up. In humans, you can't keep a person growing twice as fast by giving them twice the light. In blueberries, that works.
Now they need to rest as well. So each plant stage has the limit of hours they need of light, of photosynthesis, but they have a limit. Since they are living beings, they need to rest as well. They need to recover of their photosynthesis they're doing. If we put lights 24/7, I don't believe it's going to be the best approach, but I'll research.
Okay. Yeah, find out. Find out. Because, I mean, yeah. I mean, LEDs last a very long time with open source electronics and control systems and photovoltaics if you can store the light, if you can store that energy. That gets more complicated because if you're going to be storing energy for the night, that gets you into the solar hydrogen economy. So we would need to do that for free electricity at night, unless you're doing wind or other things. See what I'm saying?
Yes, I was thinking about the video you uploaded on Instagram that when you use water, you're able to hold electricity there, most of it. Could that apply to these kind of systems?
Well, the the thing is that you're replacing electrically generated heat by storing water, hot or cold water. So no, it's you're storing it in thermal energy, not electrical energy.
Okay, and I don't need heat. I would need maybe the opposite.
Cool.
Yeah.
Oh, so what could apply here is with a zero marginal cost thermal battery, if you want to do season extension and you're cooling the plants. Yeah, I mean that we're getting a little far out there, but yeah, just
Yes.
saying. Um, since we're exploring things, okay. Um, let's review the steps. Step one: prove biochar plastic media works. Build printer. Print first sample pot. That's good. So then you're testing out the printer. Now we were starting to print the medium. Mixed biochar. Design pot with integrated growing medium. We got to keep going here. Now we got to make biochar integrated filament. Yeah, so this is where we do the heavy hitting. This is getting the shredders and filament makers. Mm-hmm. And
I saw
then
a
test.
website.
Go ahead.
Sorry,
Go ahead.
I saw a website called Precious Plastic. They're from Netherlands. They have
Yes, yes.
some data. Would you use that kind of design, or you have some other
Oh yeah,
recommendation?
yeah. Their shredder is good. Yeah, that it's an open design. That's good. Good stuff. Now I think yeah, we could get away with that. They're using electric motors for us. That's a big expense. So we like to go hydraulic on that kind of drive. So because the motors are expensive, and if you already have an auger drive elsewhere as an integrated product ecology, you don't need those motors. So you could do it even better. Yeah, but I like it. That's good. Full open. Um, that's one of the contenders. Are we gonna do that kind of shredder? We also did an early prototype of a shredder that never completed, but that was hydraulic drive. I mean, super heavy duty, like with 1/2-inch blades. So more heavy duty. The precious plastic is 1/4-inch blades. So we're just going to 1/2 inch, which is more industrial scale, just heavy industrial. Because we were looking at things like, oh yeah, scale that up to shred metal too, so that level. So
Okay.
yeah, yeah. So when we're recycling, car parts, cars, just shred that car or whatever.
Yes, makes sense.
Yeah. Okay. So we're doing. Yeah, I mean this is shredder, filament maker. That's basically it. Now, for the filament maker, so Dr. Pierce was suggesting, oh, well, why don't you print with pellets? Just shredded pellets already, because that exists. Yeah, it saves you. You don't have to make filament, but the print head is much more expensive. So you either invest, if you're trying to do multiple print heads, that's going to get expensive. With our system right now, we have a very low cost print head, like $50 to $100. This you get more like $500 for a thing that takes plastic, melts it, and extrudes. So basically, it's a 3D printed mounted filament maker, effectively. A filament maker is a thing that melts plastic and turns it into a string of filament. So the concept there is, oh, you're actually printing with that already. You're skipping the filament making step. Well, that sounds cool. But if you do production printing, you're limited by performance of that, by cost of that thing, and it's heavier. It's a bigger thing. So if you have filament already, it's much easier to print with, lower cost print head. However, there's that issue that plastic can be recycled about 5 times or so before, like every time it loses like 20% of its properties, which is yeah. But if we're printing something that we don't really plan on destroying that anytime soon, that's a different story, I think. So
Yes, and honestly, at least in Mexico, we don't have a recycling culture. If you follow like the plastic they say they recycle, they just throw it away. What I mean by this is not talking bad about where I live. It's just most of the plastic has never been recycled. And we're
yeah,
talking about the
yeah,
pots should last 8 years. We recycle 5 times that. It's a 4-year design.
yeah, yeah. I think you're right. It's the thing we're trying to solve for is recycling at all, which means which means forget about. I mean, Dr. Pierce likes that idea, but I don't think that's. See, we're the guys ass in the grass, right? So I think we have to take priority
Agree.
in terms. Okay,
Yes.
sounds good. So we're not gonna do any like pellet extrusion. We're gonna make filament. Yeah. So
Yes.
filament maker, and then
For now, yes.
yeah. Okay, and then what do we do? What do we do after that? We take this to the ground. So this is all bench top. Is a lab. Next is take it to the ground. Take it to the field. Take it to the field. I mean, those steps can, because this is an integrated design process, all these steps could happen at any order. If we have enough people, right, any of these steps could happen in any order, unless you're limited by people. Because what we just described, if you have bodies, then each person could do it. So this makes me think again, man, we need a dedicated team to support you. Like we got that's like OSC Mexico stuff territory, snapping up some land and inviting hordes of people from all over the world because they can actually get into the country.
I agree at some point, but at the end, you have a lot of experience on your wiki of most of these things. How can it be made? I mean, with a 3D printer, with the designs, in my perspective, it would be more of understanding each design. If we're talking about the pots, if we're talking about the media, if we're talking about the irrigation system, just be able to assign how big, small these are going to be, and then print that. Isn't that the case of this? Since we're talking about very fixed items, such as a pot, such as a drip line.
Yeah, yes. I'm just saying, paralleling the process, contemporaneous, basically parallel engineering here. Uh, that all takes time, right? So I'm just saying, divide the tasks. I mean, yes, of course we could do it, but you're saying, okay, how much time in a day do we have? And each of these has to go through like 100 iterations.
Yes.
That's where the bodies come in. That's the way I think. This is, once again, this is the 1% inspiration and 99% perspiration thing.
Agree.
That's what I'm talking about.
Yes, and if we find the bodies, as you mentioned, that would be perfect.
Yeah, and now we don't have them, so we gotta start just seed it and continue going until the momentum builds. And the cool thing is that we've got good motivation because there's a real economic case for doing this. So once this succeeds, it's like everybody will be doing it. And at a point where it becomes very obvious that we're about to do it, that's when a lot of people are going to jump on. That's what's happening with the Seed Eco Home right now. People are jumping on because they're seeing the beauty and the truth.
Yeah, I saw your YouTube video where you talked with four guys and they were discussing about all the benefits.
Oh, the recent one.
Yes.
Yeah. That didn't go through, by the way, but yeah, none of them are signing up. I get that kind of shit all the time.
Okay.
No, it's interesting. It's one of those insight. They did not really understand that. Like they thought, oh yeah, we're just gonna do it, and it's like, wait a minute, guys, you need like a trained crew and people who know what they're talking about. How are you gonna do that? And they kind of missed that point. So they thought that the cost is 100, like sale price. So they really missed the boat on it. And it's a question of like, yeah, it's one of those things where people come at it, and some people just come into it and they really don't understand a lot about it, and you think that you're on the same page, but then you're not. That was the case.
Happens.
Yeah.
Okay.
But here, yeah, I mean the same applies. Like, well, here it's you've got a very refined. Like, I think the focus, like blueberries, like growing pots, it's very focused, kind of a tight thing. I think it's much easier to explain than like solving housing. It's easier. Yeah. But the water desalination, I think that's going to be a big hit too. And we didn't even talk about, but this is going to get to that. But we're starting with this. Mm-hmm.
Correct. I believe this is step one because based on this and how much liters we're gonna need, then we can find out how many liters of water on desalination we need to make a design for. We
Yep.
could start out with that, but in my perspective, this is step one. Open to you, to your view of things.
Yeah. Yep. And yeah, let's do it. So let's maybe start wrapping up. So what do we do for next time?
I'm gonna have structure what I can find here of the 3D printer based on the OC model. I'm gonna have to find the pots, and what I mean by this is the structure of it, of height, width, and the specific measures that we need to know of. The cost of current biochar I can find here. Cost of plastics, which I did already, but just with a real quote. And I would say that should be enough for a week.
Yeah. I'm Googling it. It would be interesting if, I wonder if there's anybody that built an open source Ecology 3D printer in Mexico. I don't know of anything. I just asked Chat GPT. Are there projects in Mexico who have replicated open source Ecology's 3D, open source 3D printers? No. I could start asking.
There are certain maker spaces, but I haven't found some specific with open source ecology machinery.
Mm-hmm. Are there any Mexican open source 3D printers?
Not that I have heard of. I understand they buy the commercial ones and they open the spaces so makers can go there and start building their devices or inventions.
Yeah. Well, then that's going to be easy. You have no competition.
Yes, and I'm very niche focused for now.
Yeah. Yeah. Okay. Yeah, that sounds good. So yeah, we're making progress. This is good. This is exciting. Just exciting treats every week. Okay. So yeah, with that aquaponics slash hydroponic thing, comment about the pot that I just said. It's got a shell, but most of the inside, just a shell that's got the biochar in it, or even coco coir, and then interior could be just mostly the aeroponic medium. So already there we're winning. So in this plan that we have, we should probably maybe mention something about that. Design pot with integrated growing medium, but also we should design aeroponics space with. So this goes back to my thing on slide number 3. Right? Because does that make sense to you or no?
What would be the purpose of the aeroponic space?
Free materials. The best way to build something is, remember my thing, what's the best way to build something? Is not to build it at all. Don't use it if you don't need it. So aeroponics, you need no medium for that, just the space. So that means cost reduction on medium.
Okay. All clear. Yes.
Okay. So design pot with aeroponic space surrounded by even coco coir or biochar as a means to store the water, right? So you have protection for your aeroponic space, right?
Yes.
Yeah.
I would love to just stay away of coco coir or any kind of media since it's expensive and it's hard to maintain.
Yeah. But you have to say that only after experience with biochar, because you can't at this point you can't throw out the coco coir, right?
Yes, I won't be throwing it out until we define the order. This currently project is with coco coir, so I'm aware of that. It's just my wish, or most of all, my goal.
Yeah. So if you talk about a 4-year plan, like, can you formalize, like, if say, okay, I did 4 years of open source ecologies, Future Builders Academy. What's your senior project? What are you gonna develop for the world? Have you thought about that? Like, what your contribution is? I think what we want to think, the way we want to think about it, it's like, what's your minimum viable product that you think, yeah, I'll definitely do that, and it seems like, oh, that's 4 years is even too much for that. But if we talk about that as a viable commercial release, I think that's big enough already, right? Because that would be like one of the very few open source products that are out there at all, right?
Correct. If we do this in 4 years, I would be okay because of the cost reduction and the zero marginal cost scaling that I can do. That would pay by a lot what I could invest in time, energy, and the economics involved. So for me, just achieving this that we're talking now of really generating the tools of how to do zero marginal cost protected agriculture, for me, that would be all, including water desalination. Of course, that would be step number 1.1, but just after this, since I need to have a model of production of profit at some point to get some money going on. And then the water desalination could be scaled with other kind of industries. But as of now, I think that blueberry is perfect for this. Then scaling to other crops, and then scaling to other industries with this kind of methodology, which it is taking care of how we use water and where we get water.
Okay, so I got lost there because now I don't know what your minimum viable product is for 4 years. So
Oh, yeah, would be being able to scale the blueberry project with 1/10 the cost that I did before.
and that's including desalination,
Yes, that's part of the project. Correct.
desalination, pots, irrigation,
Media and media, growing media.
media, harvesting.
Um, I meant instead of cocoa coir, using the filament biochar.
No, I get it, but is harvesting included?
Oh yeah, the mechanical machinery, and later a nursery would be for me the whole system approach.
So is this minimum viable product consist of 1/10, or is it that you have to do? What if we do 1/10 and it doesn't include all those five? Is that also going to fit to your minimum viable product?
If what we're doing, the concept is one of the most expensive ones currently, yes,
Okay. This has been spoken to the world.
yes.
I like it. Okay. Okay, that's good. That's um, that's good. That's ambitious. I like it.
But doable,
It's doable. I think it's doable. I think
yes.
it. Um, if you got no help from anybody, but just like we didn't build a team, um, if it was you and me working together on that and doing, I think it's still doable. But of course, if we enlist more people, it will be much more than this. I think is my opinion on that. Hmm. I can't predict what's going to happen because 1/10 the cost, that's ambitious. And when you say 1/10, are you talking about production cost? To what point? To packaged FOB, like FOB?
Yes, it's ambitious, but we've been looking at the real cost of growing media, of pots, of tractors, all of that. I have seen that it's possible to do it at least 1/10. And those are the biggest costs. The automation controllers, the electronics, the artworks. You have experience on doing that at least 1/10. That's what I saw on the OSC wiki. So when I transfer it into the business model I'm working on, it's just a transferring of knowledge and adapting of what has already happened, maybe on other industries or other scales. But I see that happening now because we have the technologies available and the knowledge behind of this. That's what I saw on the wiki, and that's why I got into this program.
Yeah, yeah, I agree with
Ambitious,
you.
maybe. Impossible? No, I don't think so.
No, no, it's not impossible. I think it's perfect. I think it's perfect because this combines just a huge expense. Just everything is so ridiculously expensive. So we've got a good lead already. Yeah, yeah, yeah. I mean, it's a whole zero marginal cost argument. Yeah. Hmm.
Yes. I'm still missing the. We talked last conversation about getting the cost in Mexico, about housing materials. I'm still working on that, and I'll have it ready for you maybe next week. If earlier, I'll send it by email.
That sounds good. Yeah, perfect. I like it. Um, I completely agree with you. Once open, like just like for example, like the the MRI scan that already they've built and are scanning brains for $50,000, and the next system is in 500,000, so 10x there. Yeah, it's all real. I think it's all real. So let's leave it at that, and yeah, so yeah, look forward to next time. Send me if you get any materials before that. Okay.
I'll do. Thank you very much, Marcin.
Thank you. This is great.
Yeah.
So we'll
Bye.
talk soon. Bye bye.
Talk soon.